Go. We're team 19057 with Maggot Secure Plane Technologies. This is our team, and we'll be presenting our senior capstone for the digital alarm indicator circuit board redevelopment and 3D work instructions. We'll be going through our design day poster along with its contents. This is our design day poster. So the digital alarm indicator is part of the Maggot Secure Plane pre-flight system, which is an industry standard security system. It detects and logs any intrusion into a parked aircraft. The DAI itself is used as an interface to arm and disarm the security system and is usually placed on the outside of the aircraft. In addition, Maggot Secure Plane still currently uses work instructions printed on paper to assemble all of the aircraft components, and this called for us to create 3D work instructions for them that would ultimately make manufacturing training easier.
So for our objectives, our objective to replace the obsolete parts that were in the DAI, including its microcontroller, display, and transistor with parts in active status, and redesign its PCB, as well as create more modern work instructions with 3D software using the DAI system as a prototype. Moving to the next slide. So these are our major system requirements for the DAI system. It shall weigh no more than 6 ounces and be no bigger than 48.26 millimeters by 58.293 millimeters by 25.654 millimeters, and it shall cost no more than $1,000. For the 3D work instruction, it shall include all parts of the DAI assembly in detail and in proper configuration, and also to animate certain parts of the DAI to create a realistic 3D environment for easier assembly training. And finally, for our additional system requirements, the newly developed DAI test code, it shall be compatible with the current PCB and DAI system. And the newly developed Altium DAI circuit board schematics shall be compatible with the current DAI system, include all the required parts, and run properly.
For materials and methods, the DAI parts we chose had to fit within the same casing since we couldn't change that. And then we had to make sure that each component wouldn't be obsolete within 10 years. Moving on. We chose a display because the old 10-character displays are no longer made, so we chose an 8-character and made sure it fit within the same casing. The transistor was basically physically direct replacement, so we didn't have to change anything physically within that aspect. And then for the 3D work instructions, we wanted to choose a program that would easily fit in with Maggot's current systems, which would be SolidWorks, since they already use SolidWorks to create all of their drawings.
For the results, we were able to successfully replace all of the obsolete parts, and we were able to reflect that in an Altium file with the new PCB. Also, we were able to successfully complete the 3D work instructions using SolidWorks to show how to properly build the DAI. And we did not complete the power analysis because due to the COVID outbreak, we are not able to access the ECE labs. Moving on. This is the schematic of the circuit board, and it shows the new microcontroller, the new display and the new transistor, and all of the new wiring that we had to do, and a new linear regulator as well.
All right, let's move to the 3D works instructions. So here is the user's end of the work instruction. Basically, the workers at the production floor will only see this screen, and it has a lot of links to click. For example, over here, you can see that the blooms of this DI system, you can zoom in, zoom out, and easily see what's inside of the case so that the production worker can have a better understanding of this system. And the one neat part is it can highlight every single part of it. Then the main part of this system is the work instructions. since DAI system is a fairly simple system, it only has 4 major steps. If the worker click over here, it will show an animated animations to show how the things is being put together, along with all the word description needed. Yeah, then he can go back and change to another step. For example, this is the last step. So the advantage of this is that we can export this thing into a HTML file or a PDF so that it can be easily accessed by the workers. And also, since this is a fairly simple design, if we apply it to a complex design, it will save a lot of training time of making things. Yeah, that's the working instruction.
All right, so for our suggestion on conclusion, because of the current situation, we're not able to assemble and physically test the prototype. However, we're able to use Altium to simulate and optimize the design of the DI circuits and the PCB. Something we've learned from this project is that no matter how prepared you are, you should always expect obstacles to come up along the way. Next slide is about the SolidWorks. You just talked about this. So we know by creating a 3D design product documentation using software like SolidWorks Composer, anyone that uses SolidWorks can be able to easily integrate the composer into the routine manufacturing process. So this is going to be effective and save a lot of time, and it's going to be easier for the manufacturing assembly team to work with.
These are our references and acknowledgements, which include our sponsor, Jeff Wright at Megget Secure Plane, our mentor, Mark Brazier, and another additional acknowledgement is David Schaffner, who helped us with the Altium circuit board schematic. And thank you for listening to our presentation today.
Thank you so much.